Okay, so now that we know all about polynomials, we can look at some operations. We're going to focus on adding and subtracting in this lesson. And first, we're going to work on adding and subtracting monomials, so single terms. Example 3, how can you use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form? So again, all of our answers need to be in standard form for a final answer. And then what they want us to do is use our operations to combine like terms. So how about a reminder on what a like term is? A like term are going to be terms that have the same variable and the same exponent. Okay, so we are going to combine like terms from this polynomial. And for it to be in standard form, why don't we start with the highest degree, any terms that have the highest degree. We're going to kind of use a clumping method. So the highest degree is a 2. We have a 3x squared, and then we have an x squared. So we're just going to kind of clump those together. Do we have any x to the first powers? We have a 4x. And if we kind of look through the whole polynomial, oh, there's also a 2x. We're going to clump those together. Do we have any constant terms, an x to the 0 power, which they're not going to write in for you? So any constants, we just have that 5. And now we can combine like terms. So the operation we would use is addition, really. We have a 3x squared plus another x squared. If it helps to write the one, that is a 1x squared. So the question is, how many x squareds do you have? 3x squared and 1x squared combined to give you 4x squared. Here we clump together our x's. 4x plus 2x is 6x, so we're going to say plus 6x. And then that 5 didn't have anything to combine with, so we'll just carry that down as plus 5. This is in standard form because the degrees are going in descending order, x squared, x to the first. The constant term has a degree of 0, so that's on the end. And we just kind of identified our like terms and clumped them and then combined them. All right, so combine the like terms and write each expression in standard form. So we're going to do exactly what we did on the last one. Why don't we do some clumping of like terms and then combine them. So to get it in standard form, it's just going to be easiest if you always find the highest degree first. In this example, it's x squareds again. I see a 4x squared. Any other x squareds? There is another x squared, but because of the minus in front, that is a negative x squared. So we'll clump those. We have a negative 3x and a positive 3x. And we do not have any constant terms. So now let's just combine our like terms. 4x squared and a negative x squared combine to give you a 3x squared. If you notice when we combine, our variable and exponent are not changing whatsoever. It's just the coefficients out front, the 4 and in this case a negative 1. Negative 3x and 3x, when we combine those, we actually get 0x, and 0 times x just goes away. So we just have a 3x squared. All right, so another way of clumping like terms could look like this. You have in this polynomial some y to the third power, so let's clump those maybe in parentheses. So you have a 7y cubed, and then there's a plus 5y cubed. So we clumped those. We'll add to that any y squareds. Do we have any y squareds? We do not. Now we'll look for y to the first power. There's a negative 3y and a negative 2y, so we'll clump those together in parentheses. And then any constant terms, just that constant term out on its own, that 7. So now we can combine our like terms. 7y cubed plus 5y cubed is 12y cubed. Negative 3y minus 2y just gets more negative, negative 5y. And that plus 7 has nothing to combine with, so that just comes down.